Last video of this lesson. Solving these equations when the number over here does not match your unit circle. These problems are a little bit more complicated, and I would think of them as two steps. Your first step, you're going to solve the equation. So I have sine of x equals 0.33. So what I'm going to do is I need to get rid of this sine of x. Well, to get rid of anything, we have to do the opposite. If I want to get rid of addition, I subtract. If I want to get rid of multiplication, I divide. So I need to do the opposite of sine to get rid of it. Well, there is actually a little button on your calculator called inverse sine. And that inverse sine button is the opposite of sine, meaning they cancel each other out and now x is by itself. But what I do to one side, I had better do the other side. So I get x equals inverse sine of 0.33. Now this we're just going to type into our calculator, but we need to be careful about one thing first. Looking at our instructions, it says our solutions should be in radians. So we had better make sure our calculator is in radians as well. Here's how we do this. Here's our calc. You're going to click mode. And then down here on this line, you see radian and degree. If degree is highlighted, your calculator is in degrees. We want radians. So we're going to arrow over to radians and highlight that. And now I'm in radians. I'm good to go. So now I need to find my inverse sine. It's second. And then your sine button, you see that little inverse sine up there. And then we're going to do 0.33. So this is the answer it's given us, 0.336. That is the answer our calculator gives. X equals 0.336, I believe it was, right? Yes, perfect. Now, I said there's two steps to this because, excuse me, this is not our only answer. You may have noticed that the problems up above usually had two answers. Most of the time, these problems have two answers. Well, this problem has another answer as well. And to get the second answer, we have to do the second step, which is graphing and looking at reflections. So this answer is 0.336 radians. I'm going to put that right there. So if I look over here at this little coordinate grid I have drawn, I have 0 radians, pi halves, pi, 3 pi halves, and 2 pi, just like what is on your unit circle. Well, I converted those into decimals just by plugging them into my calculator. So pi divided by 2 in your calculator is 1.57, so on, so on, so on, so on. I just estimated. Pi is 3.14, 3 pi halves 4.71, and 2 pi is 6.28. So if I have 0.33 radians, then that's going to go about there. 0.33 is between 0 and 1.57, but mostly close to 0. So this distance right there is 0.33 radians. So I'm actually going to take this 0.33 radians and copy it over here to my second step. Right there. I know that is 0.33 radians. Now, the point right here is going to be a positive point. And I can just pull that from my unit circle. All the points in this corner will always be positive. Well, next step. This particular problem is asking about sine, which is my y value. And this particular one has a positive answer. So if it is saying that the y value is positive, well, there's one other place on this graph where the y value is positive, and that's over here. The y values are also positive. So that means we have this other angle right here, and this point is going to have the same y value because of that reflection thing. So the question now is, I need to calculate this angle. Well, I know from over here that this one is 3.14. I can also use reflections to know that if this is 0.33, this is going to be the same distance, 0.33. So if I do 3.14 and then I subtract that 0.33 distance, then I end up with that green one, which is 2.81. So that 2.81 radians is my second answer. So we're essentially saying 0.33 radians. So if you did sine of 0.33 radians, you get 0.33. And if you went in your calculator and did sine of 2.81 radians, it would also give you 0.33. Both of those are my answers. Now, this is a little bit more of a complicated process, so let's try another one. Let's try a cosine. Step 1, and then we have step 2. Step 1 is just to use a calculator and solve it out. So I'm going to do inverse cosine to both sides so that those cancel. So I get x is the inverse cosine of 0.59. Type that into my calculator and it should give you 0.939. So this is what I've got. Let's graph this 0.939. Here's 1.57. So 0.939 is going to be much closer to that 1.57 than the last one. So here's my first answer. Step 2. Graph it and look for the second answer. So right there is my 0.939. And this point, because it's in that corner, is going to be positive, positive. Okay, this is asking for cosine, which is your x value, and it is also positive. So we need to think, where else on the unit circle are the x values positive? Well, that's going to be down here. This is the other place where my x value is positive. So let's reflect it across. Reflection. There we go. And this distance is going to be the same as the first answer because of that reflection thing. But now I want to find this distance right there. Well, I know the whole circle is 6.28. So I can do 6.28 minus my blue part, 0.939. And if I do the whole circle minus this part, then I'm left with this green part. So if you just type that into your calculator, you should get 5.34. And that should be your other answer. Those are the two y values that are going to have this same answer. Or sorry, the two x values, I should have said. Okay, last one. Let's do tangent. Oops, there we go. So step 1, solve it using a calculator by doing inverse tan to both sides. This is the easy part. So I get x equals inverse tan of 1.615. Type that into your calculator and it should give you 1.016. So that is our first answer. Step 2, I need to graph this. 1.016 is going to be pretty close to my 1.57. And that point is going to be positive, positive. So this is a tangent that is positive. So if we look up at that unit circle that we did up here before, what other corner has positive tangent values? So these are all positive. This corner also has positive tangent values. So I can go down here. This corner reflection is also going to have a positive tangent value. Oh, let's do it green because that's what we've been doing. Because the point here is negative, negative, and tangent is y over x, so y divided by x is also going to be a positive. Well, this angle here is still going to be 1.016. And this flat line here is still 3.14. So if I want to find this whole angle, then I can do 3.14 plus my 1.016, and that should give me that green angle of 4.157. And that is my second answer. So that is it for today's lesson. Your homework for sticker is 4, 5, 6, and number 17. And then you can also get started on your Canvas homework.